Here's an example from Calc 1 where we use differentials to estimate the change in a function's value. So we're told that the radius is measured to within 3% of its actual value, and then we want to use that information to estimate the error in the calculation of the volume. So first thing we want to do is write down in symbols what it means to be for the radius to be measured to within 3% of its actual value. Well, what we have actually is a delta r. That is a change in r actually. It's the difference between the actual radius and the measured radius. Now, this is within 3%. If I just leave it like this, it's going to be whatever units it was, centimeters or meters or inches. But relative error, you always say what's the absolute error, and then compare it to the size of it. That's what we mean by relative error. So when they tell us the radius is measured to within 3%, they're saying that the relative error in the measurement of the radius is less than 0.03. So that's step one. Step two, they want to know the similar thing for the volume. So what they want to know is there's the difference between the calculated volume and the actual volume, and you want to divide that by the volume, and you want to know how big is that going to be. This should actually feel like a related rates question if you remember them from Calc 1. What we want to do next is find a formula involving r and v. We have one. It's the formula for the volume of a sphere. So this should be 4/3 pi r cubed, like that. Now if this is a related rates question, what we're going to do is take the derivative with respect to t, but we're not going to do that because the only variables we want are v and r. So what we're going to do is take the derivative with respect to r and then multiply both sides by dr. You did this kind of thing when you did substitution, so this shouldn't be too alien to you at this point. So I'm going to get dv is equal to 4, right? Pi r squared dr. That comes from clearing the denominators. Now this thing, this differential here, means the same thing in Calc 1 as it means here. It means that delta v should be approximately equal to 4 pi r squared delta r, like that. Now note, by the way, we don't want delta v. We want absolute value delta v over v. So I can certainly take the absolute value of both sides. Here, that's pretty painless. And now I want to divide by v. So I divide the left-hand side by v. I divide the right-hand side by v. But the v I'm going to use on the right-hand side is the one with all the r's in it. So I'm going to put over here, I'm going to put 4/3 pi r cubed. And there's going to be lots and lots of canceling, and hopefully I can get the canceling without actually breaking a marker, right? So for example, the pi is gone. Yay. Almost all the r's are gone. I have r squared there, and that's gone. The delta r is still there. The 4 is gone. The 3 flips up. So what we're going to get is, we're going to get 3 times delta r over r, like that. So I'm going to write down a conclusion over here that the size of the relative error in measuring the volume is approximately equal to 3 times delta r over r, absolute value delta r over r. But we know that the biggest the delta r over r can get is roughly 0.03. So instead of my delta r over r, I'm going to put something that I know is bigger. So this is going to be 3 times 0.03, which is 0.09, which is 9%. In other words, if we measure the radius to be within 3% of its actual value, and then we use that radius to calculate the volume, it looks like we estimate the relative error in calculating the volume would be about 9%. And that's a Calc 1 type problem.